This chapter focuses on carboxylic acid derivatives and the characteristic reaction that they undergo, which would be nucleophilic acyl substitution. As a group of compounds, or as the type of reaction, these are very important both biologically and industrially. Biologically, proteins and fats, for example, are biosynthesized by nucleophilic acyl substitution. Commercially, about 3 billion pounds of nylon, which is an amide, and 4 billion pounds of polyester, which is an ester, are made each year by nucleophilic acyl substitution. So we will learn about nucleophilic acyl substitution reactions, but first our focus is on the carboxylic acid derivatives themselves. As we consider carboxylic acid derivatives, let's begin by focusing on different categories of carbonyl-containing compounds. Keep in mind, a carbonyl is not in itself a functional group, but it is part of a functional group. And so recognizing what it's connected to be able to identify what overall type of compound it is, that's critical in identifying what types of reactions it will undergo. As we think about a carbonyl connected to some R group, in general, this is called an acyl group. And then what's connected over here determines the type of compound, its physical properties, and its chemical properties. We've already spent a lot of time talking about aldehydes and ketones. When the acyl group is connected to a hydrogen or an alkyl group, these are not among the group of carboxylic acid derivatives. Let's focus on the other compounds. If our acyl group is connected to an OH, this is a carboxylic acid. And we can think of this as kind of the parent of this whole group of carboxylic acid derivatives. If our acyl group is connected to an OR, this is an ester. An acyl group connected to a halogen is called an acyl halide or an acid halide. An acyl group connected to an oxygen that's connected to another acyl group is called a carboxylic acid anhydride. An acyl group connected to sulfur that's connected to a hydrogen or an alkyl group, this is called a thioester. An acyl group connected to nitrogen, which may be connected to hydrogens or alkyl groups, this is an amide. And finally, an acyl group connected to this phosphorus group, this is called a phosphate. And you see a lot of these in biological systems. A common factor among these compounds, different from what we see with aldehydes and ketones, is that in each case, our acyl group is connected to an electronegative element. So this makes up the group of carboxylic acid derivatives. Notice over here, though, we have this lonely compound. This is a nitrile. Nitriles are often included in the group of carboxylic acid derivatives. Notice it doesn't have the same structure. There's no acyl group here, but it's considered a carboxylic acid derivative because nitriles can be hydrolyzed to give carboxylic acids. While aldehydes and ketones undergo nucleophilic addition, all of these carboxylic acid derivatives undergo nucleophilic acyl substitution. This is the characteristic reaction that they undergo. This reaction is common for the interconversion of many of the carboxylic acid derivatives and for the preparation of different types of compounds as well. When it comes to naming carboxylic acid derivatives, it's helpful to think of the carboxylic acid itself as the base name. So this is acetic acid. Keep in mind, if we were to use the IUPAC name, this would be ethanoic acid because it's 2 carbons. So everything that we're going to talk about using acetic acid, we could also apply the same rules with ethanoic acid. This is our acetyl group. This is our acetyl group, and this is connected to a chlorine. So to name an acid chloride, we stick with the acete part, we get rid of the ic acid, and we add YL, and then this is acetyl chloride. This is the acetyl group, and this is the same acetyl group. So this would be called acetic anhydride. If we have an anhydride with different acyl groups, for example, if we have this is from formic acid, and this is from acetic acid, and then we list the groups alphabetically. So this would be acetic formic anhydride. But now I'm going to erase that so that we have room. Here, our acetyl group is part of an ester. So this is based on acetate. And then we specify the alkyl group that's connected to the oxygen side of the ester. And so this would be methyl acetate. Over here, our acyl group is connected to a nitrogen, so this is an amide, and so this one would be called acetamide or acid amide. You might hear it pronounced several different ways. Next, we have the same thing with the acetyl group connected to a nitrogen, so this is also acetamide, but now we have a methyl group substituted on the nitrogen. So the acete part is based on what's on the carbonyl side, and so then we have to specify what's connected to the nitrogen. So this would be N-methyl acetamide. And then here, our acetyl group is connected to a nitrogen that's connected to two methyls. We have to specify both alkyl groups that are on the nitrogen. So this is N-N dimethyl acetamide. Here we have a thioester. These are named like sulfur derivatives of esters. So over here, this was called methyl acetate. Well, this one is called methyl thioacetate. And finally, when our acyl group is connected to this phosphate, this is acetyl phosphate. Finally, we have our group of nitriles, and so using the IUPAC name, we have two carbons, so this would be called ethane nitrile. This would be carbon 1 and carbon 2. So the IUPAC system uses the alkane name, and then you just tack nitrile onto the end of it. The common name relates this back to acetic acid. Again, we cross out the ic acid and we add nitrile, or to make it flow better, we add O-nitrile. So the common name would be acetonitrile, where this tells us that it's two carbons, and this tells us that one of those carbons is a nitrile. Our next one, we have three carbons, so this is propane nitrile. Four carbons, butane nitrile. In some cases, when looking at a nitrile, it can be helpful to think of it as if this was a carboxylic acid, because then we know that this would be called benzoic acid. So then we get rid of the ic acid, and this would be called benzonitrile. So this takes care of the basics of naming carboxylic acid derivatives. Here we have a summary of the nomenclature of some of the carboxylic acid derivatives. So if we have a carboxylic acid, that is going to end with ic acid or oic acid. An acid halide or acyl halide, this is going to be oil halide or just YL. An acid anhydride is named acid anhydride where we specify the acyl groups. An amide ends with amide. An ester ends with OH. A thioester is called a thioate. And an acyl phosphate will end with il or oil phosphate. So when we look at the name of a compound and we need to determine the structure, the first thing is to recognize what type of compound this refers to. This is ethyl acetate, so it has the ate ending, so this must be an ester, where this is the acyl side, and then this is the alkyl group that's connected to the oxygen. So acetate would be this part, and then the ethyl group is this part. So this is the structure of ethyl acetate. Benzoyl chloride, this is an acid chloride, and let's think about benzoic acid, but then instead of being a carboxylic acid, it is an acid chloride. So this is the structure of benzoyl chloride. With N-ethylbenzamide, we know that this is an amide, and it is based on benzoic acid, but instead of being the carboxylic acid, it is an amide. Now the nitrogen is connected to one ethyl group, and it must also be connected then to one hydrogen because nitrogen likes to have 3 bonds total. So make sure that you get some practice going from structure to name and name to structure. You want to be able to recognize the type of compound based on the name, and you want to know how to name it based on the structure. But even more important is to recognize not just that there's a carbonyl, but overall what type of compound this is, because being able to identify an ester compared to a ketone is going to give you a lot of information about both the physical properties and the chemical properties or the reactions that those compounds will undergo.